So I recently updated this old open source program I maintain called Audio Visualizer Python. It was originally a Qt 4 program that I helped upgrade to Qt 5 back in 2017, and I just had to migrate it to Qt 6 and up to Pillow 12. So the first main dependency to update was Qt, and Qt is really easy to update. It wasn't very hard to update from 4 to 5, and it was really easy to update from 5 to 6. The first thing I did was a find replace to change PyQt 5 into PyQt 6. And then I just looked for all the errors, and most of them were just they renamed something. And this here on their website is a list of stuff that they actually changed. They changed how you get the desktop screen from QApplication desktop to this QScreen object, so I had to write a little bit of extra code for that. There was some other code I had to delete because they had fixed something upstream that we were fixing in our program, but otherwise it was just renaming stuff. They also changed something about how the quundo commands work. That required me to write a new class, basically just like a wrapper class, to add some compatibility for how the program expects it to work. So updating Qt was very, very easy, but then I had this problem where the classic visualizer drawn by the program uses Pillow to draw some rectangles. And here we see the code for Pillow here. It's a C extension. And the thing about this rectangle drawing code is that it wasn't actually written by me. It was some of the code that was written by the original creator of the program. And so I didn't know exactly what these coordinates were expected to be for the rectangle in the first place. All I knew is that I was getting these errors that they had added to the code. The problem is that whenever you draw a rectangle, you basically have two sets of coordinates. You have your x0 and y0 for one corner of the rectangle, and you have your x1 and y1 for another corner of the rectangle. And so in the past, Pillow would allow you to pass in some incorrectly ordered coordinates, but in this newer version they added this check where x1 has to be larger than x0 and y1 has to be larger than y0. And the only difference between the two versions was this error check. So I had to investigate why they added this error check. I had to find the code that actually drew rectangles. The first thing I tried was swapping x0 and x1 and y0 and x1 every frame depending on which one was higher, just so that it wouldn't throw up an error. But all that did was make it not throw an error but draw completely incorrect rectangles. So that didn't work. I had to go and investigate the code and see what it actually used to do when the error checking didn't exist. So I found the C code that draws a rectangle first, and I found that what it used to do is it would swap the y around. If y0 was higher than y1, it would just swap them around. So then I put that in my Python code. If y0 is less than y1, then it's y1, and if y0 is less than y1, then it's y0, so it swaps them around using this ternary. But in this draw rectangle function, it doesn't say anything about the x, it just passes the x straight into the draw line function. But then if you look in the draw line function, it enters this loop, and whenever the x is too low, it just exits the loop. And so that's why in order to fix the x, I just had to change it to say that if x1 is lower than x0, then just use x0 instead. So the plus side of all this is now the program is up to date and working on new versions, and I now have these variables actually named, so it's a little easier to explain how you could make a new visualization for this program. So in this video, I'm going to explain how you could copy-paste this original visualizer and do something else with this data. So the first thing we're going to do is we're just going to give these variables less terrible names so that they make some sense. So we're going to call this big Y chord. Or actually, let's keep it selected, press Ctrl H, find and replace everything. And the next variable, this is the biggest width here, so we're going to call this one big X chord. Now this is kind of like a medium X chord, so we'll call it middle X chord. And then this is the smallest X chord that we're going to use, so we'll call it small X chord. And then down here at the bottom, this is the smallest Y chord that we're going to use, so we're going to call it small Y chord. And now hopefully the names of these variables are a little bit more clear here. Now maybe these names for the variables will make it a little bit more clear what's happening here, because most of these X chords and Y chords are actually just based on the size of the frame. The only variable here that's changing depending on the input audio file is this spectrum value, where we're taking the iteration and we're multiplying it by 4 to grab some audio data out of this dictionary that we get passed in. Now this would be a good time to say that I don't know anything about making audio visualizations, I'm not an audio engineer, I don't know anything about this stuff. This was all code written by somebody else, and I just joined the project to help like implement this whole new GUI and component system so that it could potentially be expanded upon. So I know how this works code-wise, but in terms of like audio science and whatnot, I don't have a clue. If you're curious, or if you know something about audio, here in the toolkit /ffmpeg.py file, we have the function read audio file, and this is the function that actually calls ffmpeg and reads in the audio data, and then using numpy, it creates the complete audio array. And then if we go to the component like base class that all components inherit from, we have the preframe render method that it gets called once before exporting starts, and this method actually like registers all of these properties on the component object. One of those properties is the complete audio array, which is what was created in that function that we just looked at. So then if we go to the actual classic visualizer component, in its preframe render, it calls super to call that other method that we just looked at to get the complete audio array. So if you make a new visualizer, you can take this raw audio data and transform it however you want, but I don't really know what any of these numbers mean, so I'm not really going to mess with this transform data method, but here it is. It does a bunch more numpy stuff. Some fast Fourier transform. I know what that stands for, but I barely understand anything about it, but you know. But what it boils down to basically is that every single frame while the video is being exported, this frame render function is called after the preframe render was called once, and that preframe render transformed our data and put it into this spectrum array. So we just take the frame number that we're currently exporting, and we use that to index into this spectrum array that we created to pass that data into our drawBars function. And the drawBars is where we started, where we renamed all the coordinates. So that's where all these numbers, as I said, are not even based on that audio data. The only number here that's based on the audio data is this spectrum. So we could quite easily just copy paste this and just change the drawBars function and change this rectangle for a different shape using the same data. The main libraries you have access to in this program are NumPy for transforming data very efficiently in Python. And then for drawing libraries, you have Qt, which is good for text and stuff, but if you're just drawing most shapes and things, you're going to want to use Pillow. It's a dedicated drawing library, and there's documentation here. The main one that we use, so far anyway, is this image draw. And in image draw, we have things like drawing rectangles, which is what we're doing. So we're going to use image draw for this video. So step number one, we want to actually copy the file. So we're going to go to the src/avp folder, go to components, and this original visualizer is called original. So copy the Python file and the UI file, and then we're going to give them a new name. We'll just call that new, I guess. And we want to give these files the same name, right? So we want to have them both have the same name, just one of them with .ui and one of them with .py. So what this UI file is, we see here it's opened in Qt Widgets Designer. This is a program that lets you design a Qt Widgets UI, and it just has the UI with the settings for that component. So every component actually has just a little widget like this that it adds onto the window when you have that component selected so that you can select the settings for it. We're not going to worry about customizing this. We're just going to use the exact same settings panel that we use for the classic visualizer in our new visualizer. And then, of course, step one, we're going to want to name it something different. So we'll call it new visualizer. This here is for returning alternate names for searching it up on the command line so that you don't have to type the precise name on the command line. Here in the widget property, we set the default value of the scale and the Y, and then we add in our options to the Dropbox. So let's say we don't want to have 4 options like the classic one, we just want to have 3. So we're going to remove that, and we're going to call this one top and call this one like middle. So those are going to be our 3 options. And then down here we got the command method, which is another method that every component should have that responds to the command line. Since we changed these options, we're going to change classic to middle. Going to change this one to top, leave that one at bottom, and then remove the bottom option. And then we're going to want to change our help text down here too to make sure that that's accurate. And then this method, track widgets, just tells the core of Audio Visualizer Python to track the value of the widget So the widget that gets registered as line edit underscore viz color will have its value set to self.visColor. So this widget is called label underscore scale because that's the label next to it. The one that the user actually uses to change the value is called spinbox underscore scale. And that widget named spinbox underscore scale gets registered on the self.page variable here, as you can see. So when the user changes the value of the widget that's saved here on the self.page variable, the core of Audio Visualizer Python will notice that and set the new value of that widget to this variable, which will be self.scale. Now you want to do it this way because you want the user to be able to press Ctrl Z to undo it and stuff like that. You want to integrate with the whole core of the program, so this is how that stuff all works. So pre-frame render is called once before the video starts exporting, and it's when we call super.preframerender, passing in the quarks that we received here, that we actually get the self.complete audio array. And importantly, we have the sample size passed in here as well, which is something you're going to need to know since you're manipulating raw data like that. You don't want to get that wrong. My recommendation would be to not really change much of this stuff and just focus on seeing what we can do with the data that we have by modifying the drawBars function. So that's what we're going to do. So here's the rectangle function that we're currently using. You see it takes a sequence of 2 points, x0, y0, and x1, y1. It takes a fill, the color to fill the shape with, and an outline color and a width for the line width. Something simple that we could do is just change rectangle to rounded rectangle, like right below. You see right away that before the fill argument we have the radius argument added. We'll change this to rounded rectangle. Say radius 50. Now we're drawing 2 rectangles here. One of them is semi-transparent for extra effect. So we could leave this one pointy or have a different radius or something like that. Now we'll try running and seeing our new component and see if it works. First we need to do one more quick pass over this file to make sure we didn't forget to change the layout. So now number 1 here is middle. This one is top. And then down here we have code that actually puts it on top. So we're going to put this up where top is. And we're just going to get rid of that code. Now we should be good to actually run the program now, I think. So then if we run our program and we go to add a component, we should see that we have this new visualizer component and it gives us an error. Image draw object has no radius, no attribute radius rectangle. Oh, interesting. So this is what's going to happen if you try to make a component for this program, basically. You'll get your tracebacks in this little window here. Oh, I wrote radius rectangle instead of rounded rectangle. That's what I did. That's typical me, just a silly typo. And maybe get rid of the other one so we can see. Oh, there's a very slight difference. It's very hard to see, but if you look, those rectangles are very slightly rounded. Let's put the new one on top, and we'll make the classic one like bright pink. And then you can kind of see the rounded is the difference there, right? The pink is where it's pointy on the classic one. So the difference between those is so minor, you probably wouldn't want a whole separate component for that. If anything, that would be like a rounded rectangle checkbox for the classic visualizer. Which, if you want to make a pull request for that, I would accept that, I guess. But let's try to make something that's just a tad more complicated. So rather than spending a bunch of time learning how to draw some kind of pretty visualizer, which I don't really have the knowledge of how to do, I will just show a little bit of a more complicated example just for fun here. If you try the Conway's Game of Life component here, you can have little Pac-Mans, you can have little ducks, little peace signs. Let's just try to make little Pac-Mans that are actually aligned with the music. Of course, we have to make these yellow. So back in the components folder, the Conway's Game of Life component is called life.py. And inside life.py, we have this draw shape function that has different shape drawing functions that I wrote probably in 2017. I'm going to start by copying that because that's the part that we're going to actually use. So you see in the classic visualizer, they have basically the same code here, except the one variable is called draw and one is called drawer. We'll actually just not copy that over, but we'll note that that line that we would have copied over is essentially already here, right? That kind of helps us keep our heads or tails about it. So this rectangle represents one of these little squares where our Pac-Man would be drawn. So we can see I've copied outline shape right below rect. Now we don't actually need rect, but it'll help us understand the problem a little better because outline shape is being drawn inside of where rect is, right? So if we look at these numbers here, this here is the equivalent to y1 because it represents the bottom left corner of this rectangle where we're going to be drawing. So we're going to replace every instance of that with y1. And then we have draw point x, which is the bottom left corner, and that's going to be equal to x0. So we'll replace all of those with x0. Then this pixel width property, it's a property because it can be customized in the component, but we're just going to hard code this to 26. Let's put up here, we'll put like shape, put shape width equals 26. And then every time we see this, we're going to replace that with shape width. And then we're going to do the same thing for the height. Now, the only thing left to do is figure out what this 10th x and 10th y is. That's something we're going to go back to the life.py file to figure out. And I guess we'll see here that they are assigned using the scale function. So then scale is one of our toolkit functions that's in toolkit frames. We have functions for helping you draw stuff on a frame. So you import the scale function from there. Now hopefully we have everything we need here. We just need to change these again to be our shape width and shape height. Now in theory we should be able to comment out this rectangle entirely, so let's do that. Now the last thing to do is actually put the drawing code here because we're still drawing a rectangle. All we've done is construct a shape. So we're going to go back one more time to life.py. And here where it says if shape equals pi, we just need to copy this single line that actually draws the shape. And then we'll put that here. Make sure that we change the name to draw because we kept that name. And we can comment out this or delete it, whatever. Then we're actually not using this color 2 because that was used for the other rectangle. And we don't even need this really because what we were separating out those RGBs so that we could create the color 2. So we don't need either of those. We already have color. And then we did want to skip every second iteration of this, so let's just say if it's an even number, let's skip it. Then you see here we set all of our coordinates, one of which involves the audio data so that this actually responds to the audio data. And then we set our shape width, which is kind of like the general square around where we're going to draw this pi shape. Then we get 1/10 of this coordinate using the scale function, and we define our outline shape using all these relative numbers. Then finally we draw the shape, and then at the bottom we create a new image that is the top of the image flipped upside down. Then we create a new blank frame, and we check the settings, and if the user wants it in the middle, then we paste the flipped version and the regular version both onto the frame. If they just want on the top, then we just paste the flipped version. And if they just want on the bottom, then we just paste the regular version. Then finally, we return the final image. This function is supposed to return a pillow image object. And if we go back to frame render, which is the method that is called by the export process, it's just returning the output of drawbars directly back into the core of the program to composite it with all the other frames and create the final video. Oh, something's happening here. It looks like it worked. We got very small Pac-Mans. They're very hard to see, but let's try exporting a video and see what this looks like. Of course, they have to be yellow. Alright, let's try and export this video. Yeah, those guys were a little small, so let's just bump it up to 32 and see if we can get them to be a little bit more visible. Okay, here at 48 pixels, it actually looks pretty good, so let's make another test video. Oh, but one more thing. I realized with this version, if you lower the resolution, the shape is too big, right? That doesn't look the same. It's supposed to look the same. So in a calculator here, I typed in the width of a frame, 1920, and I divide that by what I want, 64, and I see that that's 30. So instead of 64 here, we could say width divided by 30, And then we just want to maybe make sure this is an integer, just in case that matters. We have to do the same thing for our height. Divide 1080 by 64, we get 16.875. And now it doesn't look squished, and it looks the same as it did, no matter what frame size we set it to. And that's what we want. Now I guess we can check some of these other settings. Like, these might be a bit inappropriate, because, I mean, according to the preview here, they look like they're going off the screen, but you can also change the Y here, so it's not really the end of the world. You can also change the sensitivity. Oh wow, that's interesting. I wonder what that looks like. Let's export that. Oh, that's kind of cool. Huh. So check the links in the description for links to this Pillow documentation where you can see stuff about image draw, or if you just want to modify some of the existing components and improve them or add more options to them, that would also be appreciated. If you need any help, feel free to file an issue on the GitHub, and I'll try to respond as soon as I can. And let me know in the comments if there's any interest in me making a new visualizer that just like draws a bunch of shapes aligned with the audio, like the one I demonstrated in this video. Or if you'd like to make that yourself as a practice to get involved, that would also be really cool.